Hey guys, thanks for joining us. Today we're going to do a little bit of a refresher on some different types of slices that you can do in Cura, and we're going to use the Ender 3 version 2 to print these sliced models. We'll cover things like spiralized outer contour, or Vase Mode as it's also known. We'll cover some simple settings around supports when you need to use support structures, and we'll print a simple XYZ cube. All right, so we're going to slice up a couple example models for the Ender 3 version 2 that we have here. I'm just using the standard quality 0.2mm profile. You could make some changes to here. We'll cover some of these changes as we go through and load up these models. So first, let's load a simple cube. All right, so we've imported a XYZ cube. This is good for troubleshooting ringing and a couple other issues. We can also kind of check basic printer function, dimensional accuracy, and in the case of PLA, we're probably going to want to have our cooling fan on for these overhangs on the Y and the X there. So for basic settings, let's start here in the shell. So the number of walls are the outer perimeter lines. So if we do 2 shell walls, and if each line is 0.4mm, we'll have a 0.8mm solid border around the left, right, front and back walls. On the top and bottom, we have a separate setting for those, top layers and bottom layers. So if we do 5 top layers and 5 bottom layers, then those will be 1mm thick, since each layer is 0.2mm. Now typically, if you're going to have a pretty hollow item, you'll want to bump up the top layers a little bit. You know, the first and maybe the second layer don't span across the mostly hollow infill. So those are kind of sacrificial layers, and then you'll have 5 good solid layers on top of that. If we scroll down a little bit, you have your choices of what kinds of patterns. I just leave these at lines or zigzag. Concentric doesn't look as great in my opinion. It's where it's kind of like swirling into the middle. And I'll skip by most of those other settings. As you can see, there's a ton of settings. I have most of them exposed by default. Many of these will probably be hidden for you, but the ones that we're covering here won't be because they're standard. So the infill, this is what I was talking about, where the item is mostly hollow. For something like this, we'll probably have 10% infill. And then there are a variety of different infill types. Each one kind of has a little bit of a blurb that pops up. It talks about the different patterns. Something like grid is well, it's a square kind of grid pattern, and it's solid every layer, I believe. If we read the blurb, the grid, triangle, and trihexagon, cubic, octet, and quarter cubic, cross and concentric patterns are fully printed each layer. So every layer is the same as the layer before it, from an infill perspective. There are others, like lines, where it alternates every layer. And it tells you this here, that line and zigzag swap direction every layer. So the first layer it might go this way, and then the next layer it would go just across this way. So it's an even more sparse infill than something like grid. So if you need more strength, then grid would be a better choice over line. If we scroll down, so our material temperatures, we're going to print with PLA. The PLA we're using, 200 degrees on this printer, is probably fine. And this is something that you would fine-tune yourself over time for the various filaments that you're printing. And this temperature can vary a bit from printer to printer. The build plate, probably 60 degrees is better. And for the initial layer, I might even bump that up a little bit to like 65. So the first layer is a little bit hotter than the rest, and then it stays 60 for the rest of the print. The speed. So obviously, the more you crank up the speed, the more you're going to sacrifice quality. You'll have more ringing, which is kind of an elastic kind of vibration motion as the hot end and the bed jerk from front to back as they move back and forth. We'll put this at like 65 millimeters a second. and by default it's calculated the wall speed to be half of our regular infill speed and our regular print speed. The top and bottom are again half of the 65. We can leave it at that. You know, if we want to shave off some time, we can increase that a little bit, maybe to 45 or even up to 60 if we wanted. I'll leave the rest the same. Travel speed, that's probably a little high or a lot high. This is probably still high as well. On a smaller machine, we can have faster travel speeds because there's less weight fleeing back and forth, specifically on the y-axis. And I'll leave the rest of this alone. I would not suggest using acceleration and jerk control in Cura. Let the firmware on your printer handle that. If you need to modify those, you'll make that change on your printer or in your printer's firmware. I've seen these left on before, and sometimes a Cura profile will have bonkers values in there. Retraction, so when we want the nozzle to stop printing and travel to a different area and then start printing again, we want it to suck up the filament a little bit. And since we're using a Bowden tube, you know, 5 millimeters is the default on this Ender 3 profile, I would probably have this higher. And if you notice kind of stringing back and forth, one of the things you can tweak is the amount of retract you're using and the retraction speed. We also, I like to use retract at layer change. So when it's raising the Z and going up to the next layer, it sucks up the filament first, moves up, and then continues printing. I've had it where it'll kind of leave a little bit of a glob if we don't have that on. Okay. I don't use Z hop when retracted. That means the Z will physically raise the nozzle off the surface as it's retracted and then move and then come back down. I find that leaves little kind of zits on the top surface, and I have no issue on my printer anyway, traveling without Z-hop. Print cooling, so that's what I mentioned. We have some overhangs here. If I scroll in, we can see the top of that, the top of that X there is highlighted in red because that's an overhang that should be supported. And here is actually another overhang, the top of the X. And the Y here, same kind of thing. This sharp edge here is unsupported. So we're basically printing out into thin air. So we need to cool that pretty rapidly so that it doesn't sag and kind of droop down, or at least to limit the amount of sagging that will happen on that piece. These pieces here, they would actually bridge right across that small gap, no problem, likely even without any cooling. But we're gonna leave the cooling on. We have a fan on one side on this printer, and it's kind of a thin fan. I'll probably leave it at 100% to be safe. You know, we might be able to dial that down a little bit. And obviously the hotter you print and the less fan you use, the stronger the bond between the layers, but typically that's not an issue with PLA at this fan rate, at this temperature. In this case, we don't need support. So when we have something that really needs to be supported, a larger overhang than what we're dealing with here, we'll add support structures, and we'll cover that with a different model in a second. Build plate adhesion. There are some options here to increase the adhesion between the model and the build surface. A skirt is really just a great way of purging the nozzle. I can show you if we hit slice and we go to preview, you can actually see what it's going to do. So this is the skirt. So it's leaving a 10 millimeter border, kind of, you know, untouched between the model and the skirt. It's doing 3 skirt lines around, and then it will begin to print the model. This obviously doesn't help with bed adhesion. What it allows you to do though is kind of double check that your bed is good and level, that looks perfect before you actually get printing the model. And it allows you to purge out any filament that might be, you know, sitting there cooking in your nozzle while it's heating up, but also make sure that you have filament coming out the nozzle before you actually get to the printed part. If you're having build plate adhesion issues still, and your leveling is bang on, another thing you can do is add a brim. So a brim is like a skirt, but without that gap between the skirt and the model. So these are basically touching the edge of the model, and it'll kind of peel off almost like a you know, thin layer of skin off the model itself. And sometimes it'll leave a little bit of a jarred edge at the connection point between the brim and the model. But this will give a larger surface area, especially on a small thing like a cube, to increase the amount of surface area that's bonding to the bed. Another option is a raft. I never ever use rafts myself, but this is an entire surface that the model actually sits on top of. In this case, I think it's 3 layers maybe. We can actually scale this down like this and take a look. Yeah, 1, 2, 3 layers, 4 layers, and then the model. And then you would have to peel your model off of this. Now that will leave a rough texture on the bottom of your model for sure. And as I said, I just don't use them. So I use a skirt. If we get back out of preview mode, we can see our model again. And we're not going to touch the rest of these for this example. So then we can just hit slice and print that model, and we'll see what that turns out like. Another type of model that has overhangs and needs supports. So let's load up a handle. I think I have one here. Okay, so we have a handle. We could definitely print this flat as it came in like that. But let's say that this particular model I had to print for whatever reasons like this. Let's just arrange that. There. Okay, so we can see we have this large highlighted red area here. So this is an overhang that should probably be supported. You know, if you have adequate cooling and you have your printer dialed in, you'd be able to span this relatively reasonably. You know, right up until here, it's really not floating in midair, but you'll have some potential drooping and sagging and a rough surface on the bottom. And in some cases, it's just simply not possible to just span across. So we can add supports. So we'll leave the rest of the settings the same for this demonstration. And let's go to support and check off generate support. And we have many different options. We'll leave the defaults here as shown and just hit slice and see what that generates. So again, if we preview and scale down the layers a bit, there. So we can see it prints this kind of back and forth zigzag pattern, which we've chosen zigzag here. And it's supporting everything from the model that is a 45-degree overhang or more. And this is probably very conservative. I would probably only support overhangs that are 60 degrees or more. So we can see how it pared back how far the support reaches, because this curved section here is not yet past our 60-degree threshold. So it doesn't need to be supported, or at least we've told it doesn't need to be supported. So as we increase the layers and watch how it's generated this, you can see it's printing kind of a lattice structure on top of the support structure, and then our model stretches over top of that. Now there is a gap between the supports and the model itself. It's very hard to see in this view, but there's kind of an interface surface, so that's the surface that our model is going to touch. That's that lattice pattern that we saw. That just makes it a little bit of a denser surface than that sparse zigzag we saw below. And then that's going to be touching our model, so we're going to break those two apart. And there is a 1-layer gap in between here. One of these options here will be the support Z distance. So this is the, let me just double check, I don't want to tell you a lie, but that should be the distance from the top or bottom of the support structure to the print, yes. So that is the gap that's in there. And we're leaving essentially a 1-layer thickness gap. Right? So now if there is any sagging on our print, it'll actually only sag 0.2 millimeters before it touches the support structure and rests on that. So it minimizes the potential sagging that can occur. And then if this is, you know, if we're printing too hot or if we weren't using cooling here, these would actually bond together very well, and then peeling off is going to be a nightmare. So that's how you would slice for supports. And again, there are many options that can be configured here for supports. One of them is a support roof. Yeah. So I mentioned that lattice layer, that is that denser layer that our model is spanning across right here. We can actually print what's called a roof, which is a much more solid roof structure on top of here. And I find that if I'm doing a very large span, using a roof allows me to peel it off easier. So this lattice structure is the roof. If I said don't use a support roof and sliced it like that, we should not see that lattice structure at all. Right? So that interface is not there anymore. So we'll have less surface contact area for sure, so that should make breaking it off easier, but there's more potential for sag in between these, for example. And then with the roof, we have different density options, how thick we want that roof. This roof is 4 layers thick, or 0.8 millimeters. So feel free to kind of experiment with these settings. And the density of that roof is like how dense that lattice structure is. So if I increase this to like 66%, we can see that change reflected in how dense this is. And so as I said, the denser this is, the less sagging we'll have, but the kind of the more marring you'll have on the underside of the surface of this handle object that we're printing. And then there is something called Vase Mode, or as it's known in Cura, Spiralize Outer Contour. So let's load a vase. All right, so I've opened a vase and it's too big, first of all. So this is a good example. You can see the bounds of this printer's volume, and this print is too large. So we're gonna resize that. We'll go to scale, and then we can drag these, or we can just choose a percentage. I'll just choose like maybe 50%. And now it's floating in midair in my case. So I'll just say arrange. There we go. Okay. So this is a solid object. It's got a top and a bottom, so it doesn't really look like a vase. If we choose Spiralize Outer Contour, we can use our search option up here to filter out these. So spiral, there it is. And then let's just clear, it's under special modes. So let's clear our search. Wait for everything to come back. And then special modes, here we are. So Spiralize Outer Contour. So what this does is it prints one continuous spiral of filament. There's no like layers per se. It doesn't do a layer and then stop and then move up and do the next layer. So we'll take a look at what this generates. This is typically reserved for things like vases. And you don't really have the option of doing like 2 walls thick or 3 walls thick if you want a beefier vase. That's just not an option. You would just use regular print parameters at that point. But using Vase Mode, you'll have no Z seam, you'll have no little zits between your layers or anything. It'll just be one smooth continuous layer. Takes a little while. It's a pretty big model, this one. There we go. So it says it's going to take 3 hours, 7 minutes. Probably a lie. A little bit more than that, I'm sure. If we go preview, now we see there's no top. There's only a bottom. And that makes sense. If we're just doing one continuous kind of spiral, we can't really print a top, nor would we want to. So if we zoom in and go down layer by layer here, we can actually, there's also a way in here to show the tool head itself, right here. A little bit slow, but we can see it's just a single line all the way around the perimeter, and it kind of spirals up as it does that and then continues doing that again without having to stop and change layers. Still kind of gives you a rough estimate of like how many layers that would have been, 875 or so. But you'll end up with a perfect surface. We can still adjust the number of bottom layers that we would want, much like we did bottoms and top. So this one right now, I think we left it at 5 bottom layers. So sometimes when you're doing a vase, you'd want to have a little bit more of a substantial base. I mean, you're gonna have water or something in it perhaps, but if you want to make sure that even empty, it's not easily tipped over, you could add some additional layers to increase the weight in this base area here. So that is how you do Vase Mode, Spiralize Outer Contour. And all of these will work fantastic on this printer. I think we'll get it warmed up. We'll slice these, save them to our SD card, and print them out. We're back, and the guys in the shop here printed these 3 files for us. We have the XYZ cube, Looks perfectly fine. We had good bed adhesion, so we have no lifting on the corners. And we used sharpest corner, so the start and stop of each layer is on a corner. We didn't specify a particular corner, so it will arbitrarily choose what corner to put that in. But it's a nice way to kind of hide that. Otherwise, if you choose random, you might have little blips on those start and stop points throughout the faces of your print. And there's no ghosting, layers stack nicely. We have a nice flush top surface here. So there's no over extruding happening. Pretty happy with this. Always room for more improvement, however. But that's, we're confirming that the printer is working fine. I wouldn't really use this for dimensional accuracy testing. I see people measuring their cubes all the time to see if they're 20, 20, 20. But I wouldn't really use such a small object for that. And then our overhang tests. So the underside of this handle here is where we had the support material. So this was printed like that with support material supporting this bridge. Now this bridge is small enough that, with a well-tuned printer and good part cooling, we could probably span that pretty well, just with nothing underneath it. But you definitely run the risk of drooping. And we used a roof interface so that it's a very dense interface between the top layer of that support structure and the bottom layer of this print here. Now, what that ends up resulting in is a very, very nice smooth surface to the bottom here. Yeah, it's marginally textured, but there's definitely no drooping strings or anything like that. And it's a pretty uniform surface. We don't have like marring lines from where the support structure contacted it. The downside to that is that you have a very large contact area between the print itself and the top of the support structure. So that large contact surface area can result in them bonding pretty well together, especially if we're running too hot or have inadequate part cooling. So you might need to get a chisel or a small scraper in between those two layers and kind of snap them off. But the end result, in my opinion, is worth that little extra effort. And then finally, we have the vase. And so this is done in spiralized outer contour, otherwise known as Vase Mode. We were using Cura, that's what they call it, is spiralized outer contour. This is a single extrusion thick. So this would be about 0.4 or 0.48 millimeters thick, depending on what we set our line width to and how tight we have our printer calibrated. But it's one extrusion thick. It has quite a bit of flex to it. It's extremely light, and then there's a number of bases that we selected. So this bottom would be, probably 5 to 7. I forget exactly what we selected. I have to go back and watch the video. But that gives us a little extra meat at the bottom there. And as I'm sure I mentioned before, you can increase the number of layers on the bottom to give you a little extra weight to help it be a little bit more bottom heavy, especially depending on the vase you're using or the height of the vase that you're printing as well. They can kind of be a little topply. But once you got water in it, really that's largely a moot point. This turned out great. There's nicely stacked layers, and we have no start and stop endpoints because it's one continuous spiral extrusion all the way up. So not much to say about that. And if we're lucky, it'll hold water and be watertight as well. So hopefully you found some of that useful. There's lots of settings in Cura, as I mentioned. You can feel free to expose even more than we saw in the video there, and learn what each of them does, and experiment a little bit. And there's always, as I said, room for improvement and tweaking. And some of those features I'll only use on the odd print with a specific material that has different properties that I need to kind of compensate for. So hopefully all that was useful. Remember, like and subscribe, ring the bell to get notified when we upload more videos, and leave a comment down below if you have a specific question about the Cura settings you saw today or anything else you'd like to see on the channel. Thanks for watching. It's always so crazy that PLA that's usually so rigid has so much flex when there's just one layer.